Hello everyone, I'll be discussing the problems from week 15 part A packet. So this packet has questions based on concentration, boiling point, freezing point and intermolecular forces. So let's get started. So the first question is based on the solubility. For solubility, one good rule to remember that non-polar dissolves in non-polar and polar dissolves in polar molecule. Okay, so let's look at the question. So here your solvent is water, which is a polar molecule or solvent. So only polar molecules will dissolve in water. Okay, so in this case this molecule has two hydroxyl group, this OH group, which is a polar group, and despite having two hydroxyl group, it's only slightly soluble in water, and this molecule has only one hydroxyl group instead of two. So this will be even less soluble compared to this molecule. So let's see which question is correct. So in this one, have the same solubility in water, which is not true because this one has two hydroxyl group and this one has just one. Okay, and be less soluble in water than alcohol with two OH group, and this will be your correct choice because this one has two polar group while this one has just one. So the second question is very related to the first question. In this one, your elemental iodine is much more soluble in non-polar solvent. So if this is soluble in non-polar solvent, that means this iodine is also non-polar. Okay, so which option is like best explains this behavior? So iodine has no permanent net dipole, which makes it non-polar molecule, and which is true. So there is no net dipole moment, just like you have in hydrogen. So for this one, you will have the correct answer will be A. Okay, third question is based on intermolecular interaction, which of the following should have the highest boiling point? So for the boiling point, you look at the intermolecular forces. So stronger the intermolecular force, the higher the boiling point will be. Okay, why? So what happens when you boil a liquid? So different molecules in the liquid are connected by weak intermolecular forces. So when you boil it, it changes to gas, and these weak intermolecular forces break and these molecules are no longer connected, and that's how it's get converted from liquid to gas. So if we see here, we'll to answer this question, we'll see which one has the strongest intermolecular force, because that molecule will have the highest boiling point. So if we see here, CH4, which is a non-polar molecule, there won't be any intermolecular interaction except the very weak dispersion forces. This one will have very weak dipole-dipole interaction. Same goes for the third. While for the fourth one, which is like water or alcohol, this one will have a hydrogen bonding, which is much stronger than the dipole-dipole interaction. So for the third, the correct answer will be methanol, CH3OH. Okay, so for the fourth question, it's asking you about which one is incorrect. Okay, so let's start by one. So dispersion forces are the weakest type of intermolecular interaction. So that's true. The strong intermolecular interaction in water results from hydrogen bonding. That is also true. And boiling point of S2S is lower than S2O. That is also true because water has hydrogen bonding while this one does not. And then boiling point of nonpolar substances tend to decrease with increasing molecular weight, which is not true. So this would be your correct choice. Why? Because the boiling point increases when you increase the molecular weight. Why? And in non-polar substances especially, because as you increase the molecular weight, these dispersion forces also tend to increase, and non-polar substances have only this type of interaction. So when you go to higher molecular weight, you will have stronger dispersion forces, which mean higher boiling point. Okay, so for the fifth, which of the species below does not exhibit hydrogen bonding? Okay, so hydrogen bonding, it's a dipole-dipole attraction between hydrogen, and then like when the hydrogen is connected to one of the electronegative atoms such as fluorine, nitrogen, and oxygen. So hydrogen has to be attached to one of these elements for this interaction to occur. So we will be basically seeing which of these all does not have these elements. Okay, so for the E, you have oxygen and hydrogen. Same goes for water, and this is HF. You have fluorine. In this one, you have nitrogen and hydrogen, while this one is just carbon and hydrogen. So this one does not have any hydrogen bonding. Okay. Okay, what type of attractive forces are being overcome when liquid oxygen boils at 90 K? So when you boil something, you're breaking the intermolecular forces. So we have to check for oxygen what kind of intermolecular forces are there. So oxygen, just like hydrogen or iodine, is a overall nonpolar molecule. So you know that in nonpolar molecule, only kind of interaction you have is the weak dispersion forces. So obviously this is going to be your correct answer. Ionic bonds is not correct because there is no ion. And dipole-dipole forces, there is no dipole in the molecule because the net dipole is 0, so this won't be correct. Covalent bond, it's not like breaking it, it's just changing from this to this. So you're not breaking any covalent bond. There is no hydrogen bond, so there is no possibility that you'll be breaking the hydrogen bonds. So next question is, which of the following elements has the highest boiling point? So let's see. You have argon, neon, helium. So these are example of noble gases, and you know that these are inert, which means there is no intermolecular interaction. So when you don't have any intermolecular interaction, what does that mean? It means that it will have very low boiling point, or it would prefer to be in gaseous state most of the time. Okay, so you cross these and you have fluorine and bromine. So both of these molecules are from the same column in the periodic table, if you see. So I discussed before, and also these are non-polar molecule, just like oxygen or this. We had another question. Okay, let's forget it. Yeah, so just like oxygen, these two are also nonpolar molecule, and only kind of interaction, intermolecular interaction you have is dispersion forces. So I said that dispersion forces tend to increase when you increase the molecular weight. So between fluorine and bromine, the bromine is high molecular weight compared to fluorine. So this will be your correct answer. Next question. Which of the following shows a hydrogen bonding interaction? So this is very similar to fifth question. So here we discuss that hydrogen has to be connected to one of these elements, fluorine, nitrogen, or oxygen. So let's see. Yeah, so nitrogen and hydrogen is correct, and rest are wrong. Okay. Ninth question is, which of the following compound would you expect exhibit only London dispersion forces in a pure sample of that compound? So only these forces, which means your molecule is non-polar. Okay, so there is 4, you can see. Okay, so carbon tetrachloride, it's the tetrahedral molecule. If you draw it, so it's an example of non-polar molecule because the net dipole would be 0 in this case. All these 4 bonds, these bonds are polar, but the net dipole would be 0 because it just cancels out. So your first option will be correct for this question, because this is non-polar. Okay, next question. Okay, so when you add any salt in a solvent, the boiling point increases. So in this, you have the same concentration of these salts. So what you're gonna look for this question is that which one has like the maximum amount of charges. So when you put sodium chloride in the water, it's going to dissociate into Na plus and Cl minus, and this going to dissociate into Na plus and SO4 2 minus, and this one 3 Na plus. Similarly, this one K plus NO3 minus, and this one 2K SO4 2 minus. So the number of ions you have in solution in this case is 2, 1 plus 1, and this case 3, this one 4, 2, and then 3. Okay, so for the same concentration you have 4 ions for this case, which means the more the number of ions you have in the solution, the more increase in the boiling point would be. So for this one, the C will be correct. Okay. Which of the following concentration units changes with temperature? Okay, so molality is defined as number of moles divided by weight of solvent. So when you increase or decrease the temperature, neither of this is going to change because it's gonna be remain constant, weight of the solvent and number of moles. That means that this molality does not depend on the temperature, and same goes for mole fraction also, which is defined as amount, I mean the number of mole of one component divided by total moles. So the number of moles does not depend on the temperature, so this one is also not going to be correct answer. Same goes for mass percent, because mass or number of moles does not depend on the temperature, while molarity is defined as number of moles divided by volume, and you know that volume changes with the temperature, so this unit of concentration depends on the temperature. Okay. The next question is, which one of these will be most soluble in a non-polar solvent such as carbon tetrachloride? So non-polar solvents in non-polar solvent only non-polar molecules would dissolve, so we have to see among all this which one is non-polar. So sodium chloride is ionic salt, water is a polar molecule, molecular iodine is a non-polar molecule, this one is also ion, and this one is salt. So your correct answer will be C. Next question is, what is the mole fraction of water in a solution that contains 18 gram of water and 92 gram of ethyl alcohol? So to calculate the mole fraction of water, what you do, first you find the number of moles of water, which will be in this case 18 gram divided by the molecular weight, which is 18 gram per mole, which is going to be 1 mole. Okay, and then the number of moles of ethyl alcohol, is going to be the mass of this ethyl alcohol, which is 92 gram divided by 46 gram per mole. So this is going to be around how much? 2. Okay, so now you have the number of moles of both water and ethyl alcohol. So to find the mole fraction of water, which is, let's say, denoted by this, is going to be the number of moles of water divided by number of moles of water plus number of moles of ethyl alcohol. So you calculated this, so it's going to be from here. Okay, 1 mole divided by 1 plus 2 mole. So remember, the mole fraction is a number, it does not have any unit, so it's going to be 1 by 3, which is 0.33. So your B will be the correct answer. Okay, so next question asks you about the vapor pressure of water over a solution. So for this you're gonna use this equation, which is called P solvent is equal to okay. Yeah, so this is your this will be your vapor pressure of your pure water. This is the mole fraction of solvent, and this is the vapor pressure in the solution. Okay, so to calculate the vapor pressure of water in the solution, first we have to find out what is the mole fraction of the solvent, which in this case is water. Okay, so to do that, what we are gonna do is you have to find the number of moles of water divided by number of moles of water plus number of moles of, we have here sucrose. Okay, so number of moles of water is going to be, yeah, how much do you have here? 225 gram divided by the molecular weight, which is 12.5 mole. And then for sucrose, it's going to be 100 gram. You have 100 gram divided by 342 gram per mole. Which is going to be 0.29 mole. Okay, so now you can calculate the mole fraction of your water. So it's going to be this 12.5 divided by 12.5 plus 0.29 mole, which is going to be 0.977. Okay, so now you have the mole fraction of your water. So now you can put it in this equation. So simply you have mole fraction is 0.977, and you multiply by the vapor pressure of pure water. So you have here 526 torr. So if you multiply that, you're going to get 514 torr. So your correct answer will be B. Okay, let's erase all these. Okay, the next question is, which of the following solution would have the highest freezing point? Okay, so okay, so what happens when you add salt in a pure solvent? Your freezing point decreases. So this is the opposite of the boiling point. What happens in the boiling point? So when you add the salt solution in a solvent, your boiling point increases while the freezing point decreases. Okay, so this question is related to the question that we did it before. So here you can see, so this one was about boiling point, while this one is about freezing point. So okay, so all of them have the same concentration, but the way they dissociate is going to be different. So first one is going to dissociate as Na plus Cl minus. This one is Mg2 plus Cl minus. And this one is going to be Fe3 plus 3Cl minus. This one is going to be this one is going to be NH4 plus 3, because you have 3 here, and then PO4. Yeah. Okay. So the more higher the number of ions you have, the more the freezing point is going to decrease. So the question is asking you which one would have the highest freezing point. What does that mean? That means is the for which one of these the freezing point is going to decrease the least. So for that you should have the least number of ions. So we are gonna check which one of this has the least number of ions. So this one you have the number of ions 2, for this is 3, for this it's 4, for this it's 3, and this one 4. So for NaCl the number of ions you just have 2. So this one will be your correct answer. Okay, so for the next question, 16, is the average concentration of cholesterol in human is this. What is the average molar concentration of cholesterol? Okay, so you know that molarity is moles per liter, and this liter volume is solvent. Okay, so you have, it's given here, you have 0.195 grams per 100 ml. Okay, so what does that mean? It means you have, if you multiply by 10 here, you have 1.95 gram of cholesterol in 1000 ml, which is equal to 1 liter. Okay, so you have 1.95 gram of cholesterol in 1 liter. So your molarity is number of moles in 1 liter. So you're gonna find out from here what is the number of moles of cholesterol. So to calculate the number of moles of cholesterol, you're gonna divide this 1.95 grams by the molar mass of cholesterol, so which is here 386 gram per mole, which is equal to, yeah, and then you have, so this will be your number of moles, and yeah, volume is 1 liter. So if you calculate that, it's going to come around 5.05 into 10 to the power minus 3 mole per liter. Okay, so for this one, 10 to the power minus 3 The B will be correct answer. Okay, so the next question is about mole fraction. What is the mole fraction of water in a solution containing 36 gram of water and 60 gram of acetic acid? Okay, so you're going to do it in the same way. So to find out the mole fraction of water, you have to take the number of moles of water, divide it by number of moles of water and number of moles of acetic acid. Okay, so let's calculate these two. Number of moles of water is the weight of the water divided by the molar mass of the water. So weight is 36 gram and molar mass is 18 grams. So okay, so this is 2 mole, and number of moles of acetic acid is going to be 60 gram divided by 60 gram per mole, which is 1 mole. Okay, so now you have these two values, you can calculate the mole fraction easily. So 2 mole divided by 2 mole plus 1 mole, which is going to be 2 divided by 3. Yeah, so this will be your answer for this. Next question is, what is the molar mass of solute in the solution in the not this one, I jumped one question. Yeah, so for 17 the answer is 2 by 3. So 18 is a lengthy question, so to do that, let's erase all these. Okay, so 18 is asking you have 0.534 gram of solute dissolved in 15 gram of water. The freezing point if water is reduced from 0 to minus 1.57. You have depression constant, which is 1.85. What is the molar concentration of the solute in the solution? Okay, so for this one you're gonna use this equation, which is delta TF is equal to KF into M. Okay, so what are these things? So delta TF is the change in freezing point, KF is your freezing point depression constant, which is given, and M is the molality of solute, which is what this question is asking you to calculate. Okay, so the freezing point is changing from 0 to minus 1.57, so it's going to be minus 1.57, which is change is 1.57 degrees centigrade. So we just put all the values in this equation. Is going to be KF 1.85 into M. So if you solve this, you get around 0.849 . mole per kg, which is the unit of molality. So the answer for this one is going to be, yeah, 0.849. Okay. Next question is asking you what is the molar mass of the solute in the solution. Okay, so the answer that you got here is the molality. It's mole per kg of solvent. So how do you calculate the molar mass of your of your solute from here? So to do that, what we are gonna do, first we have to find out the amount of solute. So to do that, we have to multiply it by what is the amount of solvent you have. So how much you're taking, yeah, so you're dissolving in 15 gram of water. So 15 gram is 15 divided by 1000 kilograms. So you get around 0.015 kg of water. So multiply this by this molality, 0.849. Okay, so when you multiply this, you get 0.0127. So this is your amount of solute or number of moles of solute. And the question is asking you to calculate the molar mass. So you have the number of moles that you just calculated here, and you have the weight of the solute. So when you have the weight of the solute and the number of moles, you can calculate the molar mass easily just by this. Molar mass is going to be number of moles divided by, sorry, it's going to be weight divided by number of moles. So weight, you have, how much you have here, 0.534, and the number of moles is 0.0127. So you get around 42 gram per mole. So this is going to be the answer for this 19. Okay, the next question is about vapor pressure and boiling point. So you have been given the atmospheric pressure in these two cities and asking you about the boiling point. Okay, so first you have to find out how the boiling point depends on the atmospheric pressure. So the boiling point is defined as the pressure at which the vapor pressure is equal to atmospheric pressure. Okay, so this is what boiling point is. It is the vapor pressure when it is equal to the atmospheric pressure. That's when your liquid starts boiling. So the higher the atmospheric pressure, higher will be the boiling point. So you just see which one has the high boiling point, high atmospheric pressure. So yeah, Indiana has higher atmospheric pressure, which means it will have, in this area you will have the boiling point of water will be higher compared to the other city. So for this one, your correct answer will be, yeah, A, because there you have lower atmospheric pressure. Okay, next question is also calculation. Yeah, I think all these last 4 questions are calculation, so let's do it. Calculate the molar concentration of ethyl alcohol in a solution that contains 4.6 gram of ethyl alcohol and 500 grams of water. Okay, so it's asking you molar concentration, remember, not molar. So to calculate that, you have to find the number of moles of ethyl alcohol divided by weight of water in kg. Remember that the unit is important here. Okay, so to calculate the number of moles of ethanol, you're gonna divide the weight of ethanol, which is 4.6 gram, by the molar mass of ethanol, which is 46 gram per mole. So it's equal to 0.1 mole. Okay, so now you can put this value in this. So you have 0.1 mole ethanol divided by weight of water, which is 500 grams. To convert it into kg, you have to multiply by 1/1000. Okay, so if you solve this, you get around 0.2 mole per kg. So the answer for this is 0.2. Okay. Okay, this one, next question is about the depression of freezing point. You have been given the weight of your solute and the weight of solvent, and then how much change in the freezing point is occurring, and you need to calculate the molar mass of your solute from here. Okay, so how to approach this problem? Okay, so we are gonna use the same equation as before. Okay, so here you delta TF is 1.89 Kf is 1.86, and your m is the molality of solute. So if you solve this, you're gonna get 1.02 m. Okay, so remember, this is the molality of solute, and the question is asking you the molar mass of solute. So to calculate the molar mass of solute, first you have to, this is in mole per kg, so you have to find out how many moles are there. Okay, so to do that, as we did before in the previous question, not previous question, question before that, so you have 13 gram of water. So first you need to convert it to kilograms, so which is going to be 13 gram divided by 1000 kg, which is 0.013. Okay, so you're gonna multiply this value 1 point. So to calculate the number of moles or amount of solute, is you're gonna multiply this 1.02, which is in mole per kg, and then you have 0.013 kg water. You're gonna get so whatever number you get from here, which will be around 0.0132. Okay, so to calculate the molar mass, you're gonna take the weight of solute and divide it by the amount of solute. So in the question, you have been given the weight of the solute is 0.795, and the amount of solute is around 0.0132 mole. If you divide this, you're gonna get around 60 gram per mole, which is the molar mass of your solute. So for this one is 60 gram per mole. Okay, next question is molar mass of nicotine. If you have this mass of nicotine and this mass of water, and then freezing point below the freezing point. Okay, so this question is similar to the previous question that we did here, so you're gonna do the same process again as I did it here. So I'm just gonna solve it quick. So for that, you put the values in the equation here. So first you're gonna calculate the molality of your solute, which is in this case is nicotine. So your M is going to be delta TF divided by KF. So it's going below 0.563, and KF is 1.85. So which is 0.304 m. So remember, this is the molality of nicotine. Okay, but the question is asking you the molar mass of nicotine. Okay, so you have to convert the mass of water first to kg and then multiply that with the molality. Okay, so to that, calculate the number of mole of nicotine. You're gonna multiply the molality, which is 0.304, into the weight of the solvent, which is in kg. You have to take 73.4 gram. So when you convert to that to 73.4 gram divided by 1000 kg. Okay, it's going to be around 0.0223 mole. Okay, so you have the number of moles of nicotine, and you have the weight of the nicotine, which is 3.62 gram. So now you can calculate the molar mass of nicotine from here, which is weight of nicotine divided by the number of moles of nicotine. So how much do you have? It's 3.62. And then the number of moles we just calculated here, which is 0.0223. So you get around 162.3 gram per mole. So this is the molar mass of nicotine. So for this one, the answer will be 162.3 gram per mole. Okay, so next question is, which freezes at a lower temperature, hard water or soft water? Okay, so you know that in hard water you have lots of salts, which means you have lots of ions. So what happens when you add salt to the water, pure water? So when you add the salt, the freezing point decreases. So the answer for this one easily will be hard water, because you have the salt and that is going to decrease the freezing point of that water. Okay, next question is, calculate the total vapor pressure of a solution which is prepared by dissolving this mole of pentane into 0.95 mole of hexane. And then it's given the vapor pressure of pure pentane and hexane is this. Okay, So to calculate this, we are gonna use this equation, which is the vapor pressure of hexane is going to be the mole fraction of hexane into the vapor pressure of hexane in vapor pressure of pure hexane. Okay, so the same you can do for pentane also. So the vapor pressure of pentane is going to be the mole fraction of pentane into the vapor pressure of pure pentane. Okay, so first we need to calculate the mole fraction of hexane and pentane. So from here, so you have the moles of pentane and hexane both, so you can calculate that easily. So let's do it. So the vapor pressure of hexane, so remember this is the partial pressure, partial vapor pressure. Okay, so the partial vapor pressure of hexane is going to be the mole fraction of hexane. So the mole fraction of hexane is the number of moles of hexane, which is 0.95 divided by the total number of moles. So you're going to add the moles of hexane and pentane both. So 0.95 plus 0.45. So this will be your mole fraction of hexane, and multiply this by the vapor pressure of pure hexane, which is in this case 150 torr. Okay, so we are going to do the same for pentane also. So in this, to find the mole fraction of pentane, you're gonna take the number of moles of pentane and divide it by the total number of moles. And multiply this by the vapor pressure of pure pentane, which is 511 torr. Okay, so when you solve that, you're gonna get 101.79, and for this one you're gonna get 164.25 torr. So remember, the question is asking about the total vapor pressure of a solution. So to calculate the total vapor pressure, you're gonna add these two. So the total vapor pressure is defined as the partial vapor pressure of all the components. So here you have just two components, hexane and pentane. So you are gonna add the partial vapor pressure of hexane and pentane. Which is 266.04 torr. So the answer for this one is going to be 266. Yeah, so that was all of the questions.